Hello friends and my dear students. Today in the subject of design of machine element 1 in the unit 1, which is the 5th semester mechanical engineering B.Tech curriculum syllabus in the Rajasthan Technical University, we are going to discuss about manufacturing consideration of design. Okay, so in this first part is standardization. Okay, basically standardization is a process of implementing and developing technical standards based on consensus of different parties that include firms, user, interest groups, standards, standard organization and government. Means basically these are the particular parties like firms, users, means like companies, standard organization like ASME, ASTM and all, and governments. They used to set up some technical standard, like in during this COVID-19 situation there are in India ICMR used to set up some technical standards under which all the vaccine, all the medicines will work on. Okay, so those technical standards are called as standardization. Okay, so that, and these standardization or these standards are going to help for maximization of compatibility. Like if you are going to purchase the shaft of any metal, those shaft will come in the factor of, in the multiple of 5 mm diameters. Like if you will not get any shaft of diameter 87 mm, means that will be in the multiple of 5. Okay, so that whenever you are going to manufacture or design anything, that consideration should be there in your mind. Means that should be compatible and that should be interoperability should be there. Okay, and safety and repeatability and quality, means maintenance will also be very in the considerable amount. Okay, so that whenever you want to replace any part, you can replace if it is a standard. Okay, if your fan is not working, then you can replace it with other fan if it is of standard company or the manufacturer who are following the standard principles. So that is called as standardization, which should be followed whenever you are designing or manufacturing. Basically you are studying design of machine element, then definitely you should design the standard part, means you should follow the standardization principle in your designing. Next in the manufacturing consideration and design is interchangeability. Basically this interchangeable parts and it is the ability to select component for assembly at random and fit them together within proper tolerances. Like if you want to tie nut and bolt or you want to assemble nut and bolt, then those should be interchangeable. Okay, whenever if you want to pick up one nut from 100 pieces of nuts, and if you want to pick up one bolt from 100 pieces of bolt, then these two components should be fixed, or these two components should meet each other. Okay, so that it should satisfy the interchangeability property. Okay, what's the opposite of interchangeability is dissimilarity, imbalance, inequality, unlikeliness, differences, disagreement and unexchangeability. Okay, these are some opposite of that, means these should not be there in your design. In your design should satisfy interchangeability, or your parts of design, whatever machine elements you are going to design, that should be interchangeable. Okay, so these are the things which you have to encounter or keep in your mind whenever you are applying any kind of design of machine element principle whenever you are designing. Next is limit, fit, tolerance and surface roughness, which is a very vast topic. Maybe you have also studied in your metrology subject that what is the meaning of this limit, fit and tolerances. I will try to recall the topic first. So basically in your limit, fits, basically limits, these are the proper nomenclatures which you have to encounter. What are the limit of sizes? Like there is a lower limit, upper limit and tolerance. In between this lower limit and upper limit, the difference between this will be called as tolerance. If you are seeing it, there are two terms which are hole and shaft. Okay, so shaft and hole are going to meet. So whatever allowance is there in between hole and shaft, that or difference in the dimension, that will be called as allowance. Okay, similarly here there is a lower limit and upper limit, and that will be some tolerance. Okay, now the nominal size is, it is a size of a part specified in the drawing as a matter of convenience. Okay, so you have to specify the nominal size. What is the basic size? Basic size is the size which of the part to which all limit of variation, means tolerances are going to be applied to the final dimensioning of mating part. So that is called as basic size. Actual size is a measured dimension of the part, and limit of the size is there are two extreme permissible sizes of dimension which are called as upper limit for the higher maximum limit, whereas smallest size of the part is known as lower or minimum limit. Okay. Allowance is the difference between the basic dimension of mating parts, like mating parts are whole and shaft. These two are mating parts. So in between, the difference between these two will be called as allowance, while the difference between the limits are applied on the basic size of that. Okay. So whatever basic size of your one part like whole, that will give you the upper limit and lower limit. Okay. Next is what are the type of fits. Okay. I will conclude my session here, and I will start it or resume the next session from here only. What are the fits, tolerances and surface roughness, and I will conclude it in the next session. Thank you so much for your patience listening. Stay tuned with our Engineering College Banswara YouTube channel for more such content of different branches of engineering like mechanical engineering, civil, electrical and computer science. Thank you so much.